Okay, so the last thing to discuss for this chapter is that at some point you're asked to consider a single particle equation with a potential that is unbounded from below. And you're asked to show that having a potential that is unbounded from below is actually problematic. Now, a few times we've assumed that our energy was bounded from below. So here, I want to explain why that's a reasonable assumption. Why is it that a potential that's unbounded from below is not really sensible? Okay. Okay, so let's start off just by reviewing some things that you will know very well. So let's imagine that we'll consider a potential V of x, and the potential that we'll look at is something like a harmonic oscillator potential, okay? And let's start off by thinking classically. So classically, we certainly have a state of lowest energy. The state of lowest energy would just be the particle sitting at rest in the middle of the well. What you can also do is you can bump the particle a bit, bump the particle. So that means, hit it a little bit, bump it with your finger. Then you'll give it a little bit of kinetic energy. And what will happen is this particle will oscillate slowly in the bottom of this well. So it'll just keep oscillating around the state of lowest energy. So you'll study a solution that corresponds to small oscillations. Okay? These are two very simple things you could do for a potential that is bounded from below. And let's just say this is when we're thinking about the system in classical physics. Okay? Now, let's go quantum. So at the quantum level, what would we expect? Well, the state of lowest energy, this would be the ground state. And what would it correspond to? Well, actually, for the ground state, let's just maybe redraw the potential over here. So classically, the particle just sat there. At the quantum level, even the ground state would correspond to a little bit of motion. Why? Because you know that a particle can't sit somewhere with no velocity. If it sits somewhere, it's got a definite position, and if it's got no velocity, well, it has got a definite momentum. So the uncertainty principle really forces the particle just to have some little 0-point motion. This is often called the 0-point motion, and that's required by quantum mechanics, by the uncertainty principle. So that would be the ground state. And if we bump the particle with the small oscillations, these would be the excited states above the ground state. Excited states above the ground state. Okay. And this is the kind of physics that you would expect from a potential that is bounded from below. Okay. So now let's look at an unbounded potential. Unbounded. So what's a nice example here? Well, let's still take the harmonic oscillator, but we'll take the potential with the wrong sign, okay? So with the oscillator potential, there was a very nice minimum for the potential. Here we only have a maximum. And if you bump this particle slightly, it will never come to a state of lowest energy. The particle will accelerate forever. Okay, so forget about relativity. We're not worrying about relativity. You might worry that at some point you'll be traveling faster than the speed of light. Well, classically, that's absolutely true. The particle is falling down this infinitely high potential hill. So it can just keep losing potential energy. It'll keep moving faster and faster. Its kinetic energy will just keep increasing. And, it just continues forever. There isn't a notion of a state of lowest energy. There isn't a notion of small oscillations about that state. Nothing like that. Because there is no state of lowest energy, and this is the classical statement, that means that at the quantum level, well, there is no ground state. And that means that all of the questions that we asked about the harmonic oscillator, none of those questions make sense anymore. So what are a set of sensible questions to ask for a system with an unbounded potential? Well, I can't think of anything that you could ask. Maybe you can think of some questions, and possibly there are some questions, but I hope this has convinced you that having a potential that is unbounded from below is definitely a bit weird. And the usual questions, what's the state of lowest energy? What are the states of energy close to the state of lowest energy? So the small oscillations around the state of lowest energy, classically, or at the quantum level, what is the ground state? What are the first few excited states? Questions like that just don't make sense if your potential is unbounded. Good. And that ends this chapter. So good luck with completing the exercises, and let's move on to the next chapter.